Okay, here we are, 1.3c. Sorry these videos get to be a little bit longer than I would like, but college algebra is hard, and there are some things in there that take a little bit more time to discuss. All right, so the question says determining, I'm on example 5, page 50, determining the slope and y-intercept of the linear function. Okay, this is already in y equals mx plus b. Okay, so slope is 7 and y-intercept is negative 12. Remember, it's whatever sign is in front of that tells you the slope, so I know that my slope's going to go downhill. All right, this one right here is not in the form y equals mx plus b, so first of all, we have to do that. Okay, so we start doing some things here. Divide that and divide the whole thing by negative 3. Cancels that out, but that doesn't look very pretty either. So what we're going to do is whenever you're given multiple terms up here, you know, a negative 2x and a 12, and they're over one number, we can split that up. So what that's going to look like is negative 2x over negative 3 plus 12 over negative 3. So we can split that up, and that helps. Two negatives give me a positive, and a negative here. Well, 12 over 3 is 4, and then that negative makes it a negative, so minus 4. So y equals 2/3 minus 4. So my slope is 2 over 3, and my y-intercept is negative 4. If you have any questions on what I did there, let me know. Okay, example 6. We have some models in this lesson, in every lesson that has to do with usually business, finance, managerial stuff, social sciences, that kind of thing. And that's the main difference between this course and a college algebra course that prepares you for calculus, is it tries to apply the college algebra to your particular degree, your major, to just show that math is used in real life in your major. So as we saw in example 3, the amount of money Y remaining to be paid on the loan of $60,000 with $16,500 in interest, and this is what we did earlier, Y equals 76,500, and this was the formula they gave us. Okay, if you remember this, where X is the number of months that we paid on the loan. So you can figure out how much you owe by putting the number of months you paid on the loan. All right, so A, what are the slope and y-intercept of the graph of this function? Okay, so all you're going to do is rewrite this in the form y equals mx plus b. So we're just going to do some switching around here. Negative 12, 75x plus 76,000, sorry, I'm a little sloppy there, 76,500. So that gives us the slope of negative 1275, and it also gives us the y-intercept of 76,500. Okay, so not too bad. How does the amount owed on the loan change as the number of months increases? And you can look at the solution there. All right, page 51, constant rate of change. Rate of change is very, very important to get a grasp of, because you do use it all the time in calculus, and if you're going to move up to calculus, understanding that rate of change is very important. Okay, so let's look at that equation there from example 6 again, and notice the graph, bottom of page 50, that it is a consistently smooth straight line graph, meaning that every stinking month you will pay the same amount, and the amount you owe will decrease by $1,275. Every month it will consistently change by $1,275. That means it has a constant rate of change. The rate of change doesn't change. It's constant. It goes down the same amount. So in a linear function, when you have a straight line, the constant rate of change is equal to the slope. Okay, always when it comes to a linear function. The definition, constant rate of change, the rate of change of the linear function y equals mx plus b, which is the form, the slope-intercept form, is the constant m, the slope, of the graph of the function. The rate of change in an applied context should include appropriate units of measure. Okay, just make sure that you put dollars, months, something like that. That's what a unit of measure is. All right, so example number 7, Hispanics in the United States. Use the data and projections from 1990 to 2050. Okay, this is a previous example here. So let's look at what we've got. We've got h of x, okay, meaning that we're going to relate our y value to x. So 2, 2, 4. It's really hard to write on this iPad. I'm left-handed, and you know, those of us that are left-handed, we write upside down, and it's really hard to do that on an iPad because then your hand kind of scrapes across the screen. It makes it hard. So now I'm trying to write with my right side up, and it's very difficult. It's kind of like me writing with my wrong hand. All right, so there's the equation we're dealing with. Let's get rid of that one. With x equal to the number of years after 1990. So we're looking at 1990 to 2050. So a 60-year span there. And x equals the number of years after 1990. So the year 2050 would be, the x value would be 60, because it's 60 years after 1990. So it's asking, what is the slope of the function? The slope, obviously, if it's y equals mx plus b, it's going to be 0.224. And the y-intercept then is going to be 9.01. So it's real easy to see that graph on 1.33 in order to graph that. All right, so let's jump up to revenue, cost, and profit. At the rate I'm going, I don't know if I'm going to do this in 3 videos. Okay, so page 52. The profit is equal to the amount of money you make minus how much it costs you to produce the item. So if you make color TVs and you sell it for $900, but the cost is $500, your profit is going to be $400. Okay, so that's what we're talking about here when we're talking about profit here, revenue, which is the R, and C is the cost in order to produce it. Would include, labor, advertising, materials, all that kind of thing. I am not a business major. I was a math major, so I don't do a whole lot with business. So I'm learning this stuff as you are as far as how to apply it to the business world. So revenue then is also, like I said, it's the total amount of money you make. And that is how much money you make for the item you're selling times the number of units you sell. Okay, so those two multiplied together will give you your revenue. So if you buy, or if you sell a TV for $400 and you sell 5 of them, then your revenue is $2,000. So it's as simple as that, and I have to make it simple so that I understand it. All right, so the total cost is composed of 2 parts. Okay, the 2 parts are the fixed costs and the variable costs. So fixed costs are depreciation, rent, utilities, and those remain constant regardless of the number of units produced. Variable costs are those directly related to the number of units produced. So the total cost, often simply called the cost, is found by using the equation cost equals variable cost plus fixed costs. So remember that as we go into example 8, cost, revenue, and profit. Okay, here we go. Suppose that a company manufactures 50-inch 3D plasma TVs and sells them for $1,800. Okay, so that's how much you're selling them for. The costs incurred in the production and sale of the TVs are $400,000. Okay, to set up production before you even make a TV costs you $400,000. The fixed costs are, or wait a minute, let's see, plus $1,000 for each TV. So $400,000 just to get the production going, and then the materials and labor and insurance and advertising and everything else is going to be $1,000. So you sell them for $1,800. They cost you $1,000, plus you're trying to get that $400,000 back that you invested in the production of these doggone TVs. All right, write the profit function for the production and sale of X TVs. Okay, so here is the equation, and we're going to have to do some tweaking of this equation so that it works for this particular situation. So this is the general form of the equation. Okay, use this general form for all profit that has to do with revenue and cost. Okay, but you tweak it for every particular situation that you're dealing with. So this particular situation, selling TVs for $1,800 costs you $400,000 just to get the production up and running, and the cost of parts and labor and that kind of thing after you've paid that is $1,000 a piece. So this $400,000 that you're going to have to pay is going to come from the $800 you make after you paid the $1,000 in parts and labor and stuff. So you're going to have to sell a lot of these TVs to take this $800 and to pay off this, plus make money off of it. All right, so the total revenue for the TVs is 1,800x. Okay, because the revenue is equal to the, I had put up here earlier, price per unit times the number that you sell. So the price per unit is 1,800, and we're selling X number of units. Okay, so that's our revenue. Okay, I had put that up there earlier as dollars times the number, or hashtag there. Okay, the fixed costs. Fixed costs are $400,000. We can't do anything about that. We're stuck paying $400,000 to set everything up. So the total cost for the TVs is $1,000 times however many we sell, plus the fixed costs that we can do nothing about. Okay, so that is the total cost for the TVs. All right, so C of X is going to be equal to 1,000x plus 400,000. Okay, so that is going to be the total cost of production times and the sale of X number of units. All right, so what we have is we have our original function right there, and now we have to take the information that we were just given and try to write this into an equation that works just for this particular situation. So my profit is going to equal to my revenue, which I said was 1,800x, minus, okay, C of x, okay, which is again right here, and my C of x is that. So that's going to be 1,000x plus 400,000. And there's my new equation that I came up with, kind of. Okay, so see what I did? I found what Rx equals in this particular equation. It's 1,800x. I found C of x for this particular equation is that. I put the Rx here because it's there, and I put the C of x here because it's there. Okay, the only thing you can do at this point is simplify it a bit by taking 1,800x minus 1000x, you distribute that negative sign. So that negative goes here, and it goes here because it's in front of the parentheses. So then I can actually subtract those and get 800x minus $400,000, and that equals my P of x here. So that's what they wanted. They wanted you to write a profit function. When they ask you to write a function, they're asking you to come up with an equation given a general form of an equation like we have up here, and rewrite this so that it works for this particular example. So we have to find what Rx is for this example, what Cx is for this example, and then replace the Rx and Cx with what we found out works for this particular example, and simplify it, and there's our function. So when they ask you for a function, they're asking you for an equation. Okay, I'm going to have to go into a fourth video. Stink. I'm sorry. This just is taking so long, isn't it?